Hi everybody. Hello everyone. Are you able to hear me clearly? Uh, all right. So Randhir, I've made you one of the organizers so that you can also start the recording. So in case my machine fails, then you have the recording. All right. Randhir, are you there? Yes. Great. Thank you, Randhir. And all right. So do you see the questions window as well, Randhir? All right. Never mind. I don't think you have the visibility of the questions window. All right. So, okay, good. All right. So here we are. All right. So till last time we had discussed up to the Bloom filters. So all right. So let me quickly summarize what does it mean by Bloom filter. So quite often what happens is the searcher or the search engine is heavily busy even if you have the index. Okay, so even if you have index, sometimes your search engine is still busy because the data is so huge. So to help search engine, you what you do is you put a filter, and that filter quickly looks up in a hash table and returns the user that whether yes or no. Okay, so bloom filter is a clever technique in which, in case that hash table has confirmed that you are not existing in a table, then it's definitely no. But uh, definitely no. But it says that it exists, then you have to go and confirm. All right, let me rephrase what am I trying to say. So imagine that in your building, your security guard complains that, or your the guy who sits with the register complains that there are too many people coming and asking, and most of them actually are not allowed to go inside. Okay, all right. I think I should make a scenario a little bit more clear. Imagine that there is this guy who sits on your reception and in your organization, who sits on reception, and people come and ask him whether they exist in the list. If they exist in the list, only then they are allowed to enter in the premises. Okay, so a person comes in, he checks in the register, and if he exists in the register, he lets him in. Otherwise, he doesn't let him in. Now, this security guard has created a nice indexed register, so he can quickly jump into registers. Now, imagine this: if you have really huge register as in the physical notebooks. If you have really huge notebooks, or this security guard has a huge list of name, even though he is doing a binary search, as in he's quickly jumping into alphabetic order, still it will be sometimes very time consuming for this security person, right? Now there is a key insight here. The security person comes to you and says that lots of people come whole day and most of them do not exist in our list. Okay, most of them do not exist in our list, and it is very time consuming. So what you suggest to him is that let's keep one more security guard, okay, and let people first check with that security guard, and then in case that first check approves, only then he is allowed to check with you. So this new security guard who you have kept, who does the preliminary checking is a Bloom filter. Okay, is a Bloom filter. Now, what does this new security guard do? So instead of giving the full list of all the names, all you do is you give only the first three alphabets of all the names to this new security guard. Only first three alphabets. Okay. So so let's say security guard one has first three characters of names of all the people. Okay, so only first three characters. How many characters are possible? Such characters are possible. Anybody? How many such combinations are possible? 26 into 26 into 26. Only this much, which is hardly how much? Which is hardly 26 into 26 into 26. You can see hardly 17,000 names would be there in that list. Now, it'll be less than this. Okay. So this first security guard just have to look up a person's name in 17,000, or in case it's say first two characters, then it's only 576. Okay. If he's just keeping first two characters. Now you can see that it's only 500 names through which he has to look through. Okay. All right. Now, by now, you must have guessed that in case security guard 1 says you exist in the database, that does not necessarily means you are allowed, because security guard 1 is only checking for first two characters. Okay. He's just checking for first two characters. All right. But it gives, if somebody's first two characters do not exist in our name, in our list, okay, somebody's name first two characters do not exist in this list of security guard 1. In those cases, that person is certainly not there, right? Person is certainly not there. But if in this small list, if somebody's first two characters are matching, he may be in the list. For that, the check goes to the checking process starts with security guard 2, where he does the exhaustive search and make sure the person is allowed. All right. So this kind of scenario is called Bloom filter. So the new security guard we allotted is a Bloom filter. Now, who does? So you can see that the user comes in and says, "Hey, do you have key one?" He says, "No, I don't." Then it's definitely sure that okay, he does not exist in our list. Now, in case the another user comes in and he says that, "Hey, do you have key two?" And he says, "Yes, here is key two." In those cases, then the uh, actual query will happen over the network. Okay, the actual query will go to the storage to make sure. And here, when we do the actual testing, it may be yes or it may be no. So in case of key 3, he says yes, I do have, but then the actual search returned no. Okay, therefore, in case the first filter says yes, you are allowed to, the second filter does the exhaustive check. Otherwise, it doesn't reach. Otherwise, the second storage is not allowed. Now you can see that in this case, in one of the case, the user has been returned from here, while for this particular case there have been unnecessarily for this is good, but for the third case, where it's false positive, it is an unnecessary disk access, right? Because this person said yes unnecessarily, it was a false positive. But that's okay, because most of the cases will be rejected by the by the filter this scenario. So most of the cases, if they are false, if they are do not exist in our system, then most of the cases will be catered here. So this much traffic, the traffic which is taken care here, will not never reach here. Only in these cases when he says yes, the request goes here. Okay, so statistically, if you feel that most of the queries which are happening on your table is for non-existing record, you should enable Bloom filter. All right, is Bloom filter clear to all? So Bloom filter is by default enabled on our tables, so you don't have to do anything. Why am I discussing it here? So that Bloom filter is a general concept. It's a general popular concept in computer science. It's very much used in high-end architectures, and it's very much, and there are dedicated libraries, there are dedicated products which you can utilize in Bloom filter, specifically in caches, wherever there is a cache and there's a lot of lookup overhead. The cache can be used, can have a lot of Bloom filter implementations. All right, so that was our Bloom filter. Any questions at this point? It's a, and I think I should have said it before. This it's like a very favorite interview question of lots of people. So Bloom filter is extra layer of search, where this search will if will have a shortened form of names, or you can say hash codes of the actual names, so that hash codes are generally a small list. And when the user comes in, you can quickly say no, quickly, confidently say no, but you cannot, this Bloom filter cannot say yes confidently, because for yes, actual lookup has to go there. Because if somebody's hash code is matching, it is not necessary that actual word will also match. All right? Was I able to explain everyone? Ganpati, Martin, Naveen, Ravi, Saryu, Sridhar, and Veena. Great. Thank you, Veena. Great. All right. All right. So moving ahead. Now again, Bloom filter can be enabled per column family. You can use the set Bloom filter types, but by default it is enabled. Okay. So if none, there will be no Bloom filter. If we say row, then the hash of the row key will be added to the bottom of each insert. Bloom of, not bottom, bloom of each insert. So every time somebody is adding a row, the hash of the row key will be added as the key or the list in Bloom filter, so that when the request comes in, the first lookup goes to the Bloom, and Bloom contains the hash code of the key. That makes it really, really fast. Now, if row call the hash of row key in. Okay, so if you want, you can also add the row column, kind of Bloom filter. In that case, the hash code of a combination of the row key, column family, and column qualifier will be added to the Bloom of each key insert. All right, the way we were talking about names. So instead of name here, it will be on the full row and column. All right. So you can see more details on Bloom filters there. All right. Now, sometimes you might want to control what happens before and after any action in Headspace. And there are two basic actions which are provided by Headspace. One is get and other is put. And third is delete, of course. Okay, so for all these methods, get, put, and delete, HBase provides coprocessor handlers so that you can write your own handlers for various kinds of events. For example, here we are saying that we want to implement or extend the base region observer. We are saying override preget. So So when you say override pre-get, we basically you are saying before the user gets the value, my logic should be executed. And why would you like to execute your logic before that? So that you can enforce your own kind of a permissioning. All right. Similarly, the way we have handled pre-get, we could also handle pre-put and pre-delete, as well as there is something called post-put, post-get, and post-delete. All right. So that way you can handle a coprocessor. Coprocessor is just like your triggers in databases. And let's say you created this kind of a coprocessor. Where will you keep it? One is that you add this class name in hbase-site.xml and in this particular package. So here you can add into the name of your package and you put this whatever compiled version of jar, you put it in hbase lib folder. And then you mention this here and then restart your region server. Similarly, you will have to copy HBase site to all the nodes as well as you have to copy the jar files to all the nodes. So that's a little too much on coprocessor. Therefore, coprocessor started providing something like a very clever technique. Coprocessor starting letting you put the library inside the HDFS. Okay, so you can put the data in HDFS, and then once you have put the data into HDFS, then you could add one of the attributes like this coprocessor $1 on a particular table, and then you can mention the path to your HDFS file. All right. So you upload your jar file onto HDFS, then create this object, and after that you can say on a table set value coprocessor $1, and this is basically a sign that it has got a coprocessor. Right? So that's pretty much how do you create a coprocessor. Now, in case you want, you can use the REST client on your HBase. This is a very, very important aspect. So you can basically call the REST, make a REST calls to HBase, and this is very useful for this is very useful when you want to run your own run your own kind of a client which can directly talk to the HBase and get the work done. All right. So I'm not sure if it's being run. Let me just check HBase, and we have got HBase master. And let me have a look at the config. All right, let me check. Never mind. I think it's not there. So, all right, HBase, and then I say, all right, let me try to execute this. Let's say, uh, all right, let's say HBase REST start at this port. Okay, so it has started the service at that particular port, and now you can h1.cloudxlab.com, and there you can specify your table name, say web table. So you can see that there are these many tables. Let me just pick up this table called web table. I'm so sorry. Yeah. Here, where is my file? My table row. Okay. So yeah, data browsers. All right. So this is one table of HBase. We are saying it has got one column called contents, other column called anchors. Okay. So you can see this is our column called contents, and let me just put contents, either one or more. Okay, contents. And then what was the row key, by the way? What was the row key here? Hotandworks.com. That's our row key. Now it has given us the result. You can see that. All right. This is the data of what was there inside this table. And what is the data inside this table? You can see it's ahref microsoft.com HCD insights, and that's what it is. You can see that it is that data. All right. So that's how you can make a call to HBase from the browser, and this is quite useful in case you are running HBase on one of the subdomains. So your JavaScript can call this. All right. So this is a general scheme of URL. I hope everybody is aware of how a URL is structured. A URL is structured like this scheme, which could be HTTP, HTTPS, FTP, and so on. And then user colon password at the server name, and then the port, and then path to the file, then rest of the arguments. And the one which is after hash is something which remains on the client, doesn't reach the server. Okay, so if you want to know more about REST interface, look at a component called Stargate on REST. All right. In case you are looking for JDBC client, I would recommend Apache Phoenix, which is good to give you a JDBC kind of a client. Although it's a little bit different, but it makes it possible for you to run the SQL queries on the database. All right. So that's pretty much about the HBase. All right. That's pretty much about the HBase. Any questions at this point? All right. So we're able to talk to HBase and understand the data model in HBase. We also understood why do we need NoSQL databases and when do we need these kind of databases. All right. So now going back to Hive, which we left earlier because we were not able to connect, it seems that the command line no longer provides you the multi-session ability unless Randir's question is, could you show how we can load the web page data as per your example? Web page data as in using JavaScript? I haven't prepared that. For that, I need to prepare an example such that my website is also hosted within the same domain. Okay. For that, I'll have to prepare a proper example. But theoretically, the way we were able to make calls through browser, we should be able to do that. All right. Ranveer is saying in HBase, we were able to we loaded the data by using put. How can we automate it? Okay, good question. So one of the ways of automating is you write your one is you write Java code as I showed you in the example where we wrote some Java code to start writing to the database. Okay, there was one example in which we showed. Or second is you can write a shell program, okay, and then pipe, then what do you call run commands using the hbase hbase command. So hbase shell command can run anything. So if you look here, let me just exit from the process. So here hbase provides you various commands, okay, and here we can have what do you call status pipe hbase shell. All right, so how do you let me see, there is one argument with which you could pass a command, okay, so yeah, here is yeah, so all right, echo list. All right, so actually this hbase provides you a way to actually execute. Yeah, just let me have a look through. I got it. So what you can do is you can do things like echo list. All right. Okay. So I think there would be an argument to pass a command if you want to just run a single command. So generally, what you do is you call this hbase command with the temporary file you create. So one is you in a big file you can write put x and so on. Then you can write put this and so on. So in one big file you can create such kind of a script and then pass that as the argument to hbase shell. Okay, if you provide that as the command line here, that will be executed executed as a script. Okay, so that is one way to automate it, and the other way probably is to there would be some way to pass the command line. Okay, pass the command line. All right, so that I need to check the argument of this hbase shell. So mostly you can just write, you can write a bunch of put, get, or create table commands in a file and then pass it to hbase cell as first argument. Alright, that's how you automate it. Alright, let me increase the text a bit. Alright, so that's how you automate it, Randy. Was I able to answer your question? Yes, Martin, I have solved that problem before starting the session. You could try that out. Alright. We are looking into avoiding those kind of problems. Alright. Now that was good. So I'm able to answer your questions. Moving ahead. Alright. So we were talking about HBase and Hive, and we talked up to, I think we talked up to, alright. So we talked up to here, and when we were trying to do, so we talked about Hive, right? In Hive, you have all kind. It's basically an SQL using which you can do many kind of things. So let's try to show you the databases quickly. And a better way right now is to run the Hive queries from the browser. Okay, so you could say things like so databases. You can see the databases here. These are the databases. You could create your own databases. Right? It says there is an error near here, so probably this is the error. Alright, so we must have created one database, and we can also, so we are here in the query editors in Hive. Okay, so you have, what do we have? We have created one of the databases here for me. All right, now instead of polluting everybody's workspace, I've created my own database so that it remains with me. All right, so that's the role of databases. Also, you can have a look at describe database in Asgiri. It'll tell you all the details about it. All right, now once you have created databases, now you can run the show tables kind of command, and that should give you a clear idea. Now, What he's suggesting, Randhir is suggesting, let's go back to this problem where we have tried to create first we have tried to copy big.txt, try to copy this into our home folder. Okay, why? Because Hive would need the original copy, so we will not bother with the existing one. All right, so let's go to the file browser, make a copy of. All right, am I in somebody else's ouch. So I think I should have been logged in into this. Never mind. You can log in and then do the same thing what I'm doing. I'm just in a different login right now. Okay. So I'm trying to copy the data from here. I'm saying data, and let's say go to MR. I want to make a copy of word count input file. I'm saying action copy, and I'm saying where is my home folder. Inside home there must be asgiri or something that I must have created. Yes. All right, so I've copied the made a copy of big.txt in my home folder in hdfs so that I can fiddle with the new file and without having to worry about other things. So here I'm saying load data in this path, load data in this path into a table called docs. But before that, we need to create probably a table called docs, right? Is it, do I need to create a table called docs? Let me just try to run and then see. What does it say? Maybe I need to create HDFS colon this. Table not found docs. Okay, so the problem was not this. I just have to create table docs, and it has got, let's say, C1 as what do you call it, string, or was it text? Varchar alright. So it says that error in this. Okay, let me just put a semicolon somewhere. Okay, so now did it create the table, and what is in the table? So it has a docs table. It has got one column, and I can see the data inside. There is no data available right now. So there are no logs here. Let's try to run it separately. It says invalid path this. Okay. No, not this. And so okay. Here. I think this will work. Again, invalid path. That means what do I need to do? I need to say user slash T7974. Okay. So this exercise is important. This exercise shows that how to debug your problem and reach to. Okay. So here you can see there are no results. Why? Because uh, you can see that this is some my history of all the commands which you can copy paste, and this is what we have executed. It says that loading table this, and it has number of files 1 and so on. Now once we have loaded the data, we can say select star from docs limit 10, right? and check if some data is there or not. You can see that it is basically the same file. Now, once you have done this, now you can run your rest of the query and test what happens. Okay, the more chances are, let's see. So I'm saying create word counts as this from this. Okay, it says that invalid table alias. Oh, what happened? It says error while compiling statement, invalid table alias or column reference line. Okay, the reference is C1 here because it's a column name is C1. Okay, so it says session is already open. That's okay. That should not be a problem. Now you can see that it has started executing MapReduce. Okay, it is saying that there are going to be two reducers, and it has automatically decided on number of reducers. And okay, I think it means first of the mapper task. So it has done the job of putting the data into word counts. Let's see if it is done. Yes. So you can see that it has created this data here. It's a word count example. Okay, it's a word count example. Now, just that the data cleaning is not done correctly, we have not trimmed the strings. That's the reason it has all those kind of awkward strings. Okay. Now, going back here, you can see that it says that it is running the MapReduce and showing the progress. And after it is done, whatever was the result in this folder of this one, it is moving the file from this folder, moving the file from this temporary folder into this table location. Okay, so that's all about running a Hive query. Okay, is it clear now to everyone? Okay, so you can see that when we ran something, it actually executed the Hive command here. This is the one, I think. All right. Although there is already a Hive command running, that's okay. Right. So good. So what does explode do? Explode breaks a big sentence into array of words. Sorry, explode takes an array of words and make them each into one particular row. Okay, so it takes a array argument and convert it into one row, just opposite of group by. All right, so that was it. So even if you did not understand that example, don't worry. It's just hello world kind of thing for any big data tools. All right. So if you want to see the tables, you can say show tables and select start from table. We have already done all of this, and also say describe my table. Also, you can say describe formatted, and it will show you all the details about your table. There are two kinds of tables in Hive. Those tables, one is called manage tables, and the other is called the external tables. Okay. The only difference between manage table and external table is if you delete a managed table, the data will be deleted. But if you delete an external table, data will not be deleted. That is the prime difference between managed table and external table. All right. All right. Where is Vina's question is where is mapper and reducer being called before we move forward? So here, when we are basically running at this query, it's going to convert it into MapReduce and schedule the job on yarn and saying that here is my mapper and reducer. It will internally create that MapReduce and run it on the cluster. Does it make sense to you, Veena? Yes, Hive does it. Just like Pig did, Hive also does the same thing. Okay. Now going back to manage tables, and there are two kinds of table called one is called managed tables, other is called external tables. For when you own the data and you're okay that when this table gets dropped, you're okay with deleting the data, you keep managed table. But as a thumb rule, don't create managed tables in general. Keep things as external tables. All right, and because by mistake, if you delete it, everything will be gone. Gone in the sense that it will be in the trash. If you want, you can recover it from the trash. There is a dot trash folder in the HDFS. Whenever you delete something, it goes into trash. All right. Now, unlike Pig, if you remember Pig, where we were executing a command, say creating a data set and then using the data set. So as long as you were in the session, as long as you were in the Pig session, that data set was alive. In case you exit from the session and you join again, then you have to load the dataset as one of the sessions. Okay, and that's not. I mean, there was a duplicated effort. Therefore, in case of Hive, because in Hive we will be creating database tables, and if you exit Hive, imagine that all the database tables getting deleted. Okay, on exiting Hive, if all the database tables are getting deleted, that means, okay, so that means it will be too much of effort for us. Every time we have to churn data, we have to create table pointing to the database. So that's a very extra effort, and that's where the Hive meta store comes in. In case of Pig, again, let me remind you. So Pig was just a client. There was no server involved. The only server that was involved in case of Pig was Yarn or MapReduce. So Pig created MapReduce and created MapReduce and handed it over to the Hadoop. Okay. Now there was no other server of Pig. There was only clients. But in case of Hive, since we do not want to delete our tables every time we exit the session, right? So we created a table. If we exit, if it is deleted, then when we come again, we have to do all the process again and again. To avoid that, Hive guys created something called metastore. So the metadata of a table is kept in the metastore while the actual data is in HDFS. Make sense to you? Metadata means what is the name of table, what are the columns it has, is it a view, is it a table, or is it a managed table, is it an external table, and which database is there, what are the various databases, which table is inside which databases, and all this information is inside MySQL. I mean, by default, it is MySQL, but you can change the database to any other. Okay, so that's called metastore. Yes, that's right, Arjan. The actual data store is HDFS. Yes. All right. So let's try to create this managed table. All right. And when we are creating a managed table, let's modify it a bit in order to suit you. Okay, we are saying create a table called NYSE. There is exchange one, symbol one, YMD. So we are just creating this. Let's modify it a bit. And what is the name of our user? Our user's name is T7974. T7974. I'm using somebody else's account. Okay, and yeah, you could use your own account. So I'm creating a table. Please pay attention. So here, when I'm creating a table, I'm saying this is my table name. These are the columns and their data types. And after that, I'm saying that my data for this table physically will be stored as tab separated. Okay, the fields will be tab separated because unlike pig, it doesn't its default separator is not tab. Instead, it's control A. Okay, control A is non-visible characters. That's why they've kept it control A. And here you can skip this. If you skip location, it will create in the folder called warehouse slash app slash warehouse, and that's where it will create this table. But you can specify your own table, right? Now let's say we are creating a Hive table. We are saying this is my Hive table, and all right. So let's see. Yeah. So it has created this table called NYSE. Select star from NYSE. Okay. So you can see that there is no results. But here in my home folder, you can see that. All right. If you order it by date, yeah, you can see that there is a folder automatically created my home folder, and whatever data I push into NYSE, that will be moved to that storage of this location. Or if I don't want to import data like this, I can directly put data into this folder, and that will be visible in here. Okay, that will be visible here. I'll show you this. So this is the folder where I've specified that this is the data, this is the location of my table. Okay, this is the actual data storage. So when I load data into the table, files will be created in this folder, or I can create files in this folder to load the data into my table. Okay, I'll show you this. So let's say, all right, I think let me go through the straight route first, then we will show you the rest of it. All right, next is we can load data into that folder. And so instead of this, let's first make a copy of data. So right now, since we are running in from the browser, let's try to load data from HDFS. Also, please note that whenever we load the data into HDFS, and if it's a managed table, by default this is a managed table because we have not specified external. So if we are loading data from local directory, as in we are logged in from the shell, from the terminal, in that case, when we load data into this table, it will get um, copied to HDFS first and then moved to that location. But if your file is already in HDFS, it will get moved directly to the location of the table. I'll show you. Let me just copy the file. That file is inside data, and you can see here in Hive. not in Hive. It was somewhere. Yeah, you can see that here. NYSE daily file. Okay, you can see that. Now I can copy this file to my folder. Where is the file? Inside data. Yeah, here it is. So let me just copy it. So I'm copying it to my folder called here as Giri home folder, and I say okay. Okay, first I've copied the data to my home folder because when I load this HDFS file, it's going to be moved to the table storage. Okay, wherever is the table storage. Now let's go back to here and say we have already copied it, no worries. So we are going to save this. We're going to say load data in this path. And what was the name of the file which we just handled? NYSE daily underscore file. Daily underscore file. All right. Override into this table called NYSE. Okay. Now, when we say load data in path, it will try to load it into the table. What does it say? Invalid location. No worries. Let's just define user slash T97, not 97, 77974. Error. What was that error? No HDFS file available. Is it? NYSE daily files. Is it? NYSE daily file. Is it? F is capital. All right. So now the data has been loaded into our table, and we can say select star from NYSE limited to say 100 records. You can see that we have been successfully able to load the data from file into here. Good. Now, what happened underneath? Let's also check that out. So if you go into my folder NYSE, under this, there is what was the location of our file? Yeah, NYSE only. You can see that the this was our table storage, right? This is what we specified while creating a table. So there, this file has been moved. You can see that the file has been moved there. If we do not, say overwrite into this, it will. Oh, that file has been deleted, so we cannot do this. But so if you have more data getting imported, more and more files will come into this folder. This is the storage where it's getting done. All right. So there are a few questions. Let me answer it. What is the advantage of a metastore? Advantage of a metastore is that when we exit here, exit the session, okay, the tables are persisted. Table information is saved. Naveen Gupta's question is, do we have complex data like pig using map or tuple? Yes. but it's limited to few basic types as we talked about. Map, you remember our last discussion? I will just show you that. So these are the data types. So there is arrays, maps, unions, and structures. All right. All right. So I hope I've been able to answer. Now let me take up another question. So I did not get what you mean by copied from HDFS to location of a table. Location of table is HDFS, yes. So it moved from one HDFS folder to another HDFS folder. That's what happened. All right. I'm trying to answer Vina's question. So, good question. So, when we have this table storage and we are loading the data from HDFS, it has to basically move that file from one location to another. So now you might be wondering, why does it move? When we are loaded the data from HDFS from some source folder, why should it move? The reason is the way when you drag and drop a file from C colon one folder to another folder, it generally moves. The reason is that first, moving is faster. Second, already each file in HDFS has got 3 backup copies. So once you copy the file, it is unnecessarily 6 copies. So it's kind of a design choice that if you're trying to load data from HDFS, you most likely would be trying to move the data. And that's one reason why you should be cautious with managed table. So imagine that you already have a data in HDFS and you said you created a managed table, and after you created the managed table, you said load this particular data. Now this data will get moved into the managed table and will be deleted from the original location. And after that, after you loaded the data, now if you delete this managed table which you just created, it will delete the data and therefore the data is gone. Ganpati's question is how the create command is different for external and managed table. It's just one keyword is different. I will show you after this. Okay, I'll show you after this. All right. Now we were able to successfully load the data into our Hive table. So we were able to say select star from NYSE, and we were able to do the magic. Now we could do few more complex queries. Let's start with something like this. We are here saying select star from NYSE, where the symbol is okay. It says failed invalid table alias. Okay, here my table has table 1. You can see that. So we were able to quickly do the kind of magic. Now, if we have to just compute the average value of each symbol, we could say select symbol 1, comma average value of say price underscore high and average value of price underscore close from what was the table name? NYSE group by symbol 1. So we could do a kind of a complex query right away. So starting to do our MapReduce. Alright, you can see that it has created these 2 columns with the average values. See that? Good. So this is how you could query a Hive quickly. Alright, moving ahead. So we were successfully able to load data into our Hive table. and also churn the data. All right. Now again, if you do not specify, if you do not mention the last line, if you do not mention this, the data will get created in this default folder called apps hive warehouse. Okay, if you don't believe me, you can try to do this. All right, you can try to do this with a different name, say NYSE here. All right, now here, if you see, you can say describe formatted and NYSE1. Okay, so here in this diagram, you will be able to see the location of the file. I hope it's able to show us. Here you can see this. So it has created the folder here. Now all the data, whatever we create, whatever we push into NYSE1 is going to be in this folder in HDFS. Okay, this is the empty folder which we have created. Good, sounds good to everyone. So that's what I was trying to describe. So the location will be either the one which you have mentioned in the description. Now couple of questions arise. What if there is data already on the location, the location at which you are trying to create the table? What if there's already a data? So while creating a table, Hive basically does not delete the existing folder. So you can basically query on that folder right away. Okay. Now sometimes you may want to save the data into the file system. So if you are on the local file system in the command line, you can say insert overwrite local directory and you can save the data. Or if you are in a if you are you want to save it in HDFS, you can say things like this. You can say so let me say NYSE symbol equals to this, and I want to save it in this folder. I can simply say things like this. So what does it say? Invalid table this. That's okay. Is it running? Yeah, it's running. So I think it has created this folder. Let's try to see if it is there. So you can see here that the data has been created. Alright, so it has saved the data in this folder. Okay, and this data is by default separated by Control A, and you can further mention that you want to store data as comma separated. Okay. So we were able to successfully store the data. All right. Now there is an idea called partitions. So while we talk about all of this, let's understand what exactly is the purpose of Hive. Purpose of Hive is to provide you good amount of analytics. You should be able to clean, you should be able to process data, filter data, and pick up the data which you need. Okay, so Hive is not for inserting records, updating records, delete records, or providing the CRUD kind of operations. Hive is more like for read-only access. So Hive is generally used for analytics and and generally run on existing data warehouses, which is data is already there. And when you have existing data, then you generally have data spread over multiple files. So you can think of like this way. Say you are running a web server, you are storing the web server's log in one folder per month. Okay. every month you are changing the file, or every month it's automatically changing the file. So in those cases, you might want to load hundreds of files. You might want to create a Hive table spreading to hundreds of files, and that's where partitions come along. So partitions avoid there are multiple benefits of partitions. One is it allows you to create a uniform view over hundreds of files. Second, it helps you avoid the full file scan. Instead of partial file scan, it allows us to avoid full file scan. Instead, it allows us partial file scan, meaning if you need only few rows, like CMC we said in the previous example, in case there was a file partition for CMC section, then it will only query that particular section. Second, data stored in different file based on various combinations of various columns. I'll show you this. And you have to define the partitions using partition by in the table, and partition can happen on multiple columns. Alright. So let's try to see an example here. Alright, let's take this example called in this there is one table called the amp, and then there is another table called the amp1. Okay, so let's first create this particular table here. Okay, so alright, so we have created this table called employees. It has got three columns: name, salary, and degree. Okay, and there is a partition by statement. So it says that basically there are four columns: name, salary, degree, and fourth column is qualification. And our rows are formatted and the fields are delimited by comma because our input data is in the form of comma separated. Now when you run when you look into this, okay, let's just try to say select star from employees. You can see here what, all right, or we can say describe, right? You can see that it shows you four columns: name, salary, degree, and qualification. Qualification was our partition table, partition column. So that is our partition. So that's also considered like a column only. Now let's see. So here you can see few interesting things. One is, let's go to the data folder first and copy these two files from here, the amp and the amp1. I'm going to copy it to, let's say, my home folder and then say SKD. Alright. Alright, so I'll say home. Now I want to show you what's in the files, okay? So you can see there is a file called dm. It has got three columns. Right? I hope my machine is not going to freeze. All right. Or let me just show you from the command line. If I can show you from the command line. Oh, I can't show from the command line. Or yeah. So here we can show you. The hue has gone down. Never mind. So I'll just try to see if I can. Okay. So here now it has come back. All right. So here you can see that there is a employee table which has got these four values: Sandeep, Shravani, 10, three columns and two rows only. Okay, I've kept small data purposefully so that there is no confusion. Now the other table called the amp, there you see again there are these three columns. Let me just change it. Let me just change the file. Thankfully this hue provides us with these data. So now you can see that the amp and the amp1 both have three columns each. Now here when we create a table by importing these two files, what we can do is we can say things like uh, we have already copied the data. Yeah, we can say things like this, these two, and here we can say remove local because we are loading data from the HDFS and we are saying it's in this path called the amp and the amp1 into employees, and we are saying into employees, and the partition here we're defining. So we are hard coding the fourth column called partition. So this is something which we have to hard code because that's how we are that's how we are bringing all the data together. Okay, we have to specify the qualifications value by manual. So let's see what does it say. It says invalid path called this. Did I? Yeah. Now it has loaded the data into employees. Now after this, let me comment it out. We can say select star from employees. Now you can see that the data from both the tables came here. Sandeep 1, Shravani 1, and then there is extra column called qualification for which we have hard coded the value. This is how you generally the utilize the partitions. Now under the hood, it is creating a folder for this employees table. Let me see where is it creating the data. We can see describe, formatted, and employees. Okay. So here it will be somewhere. You can see this place. All right. So here, the important part you should note is the way it's creating folder for each partition is based on the partition criteria. Here, our partition criteria was qualification equals to something. So you can see that it has copied the amp, the one which we did load, has copied that file inside this folder, and it has created another folder called qualification equals to 2 and this. Okay. So if your data is already structured in this form, then you can just say location equals to this while creating a table, and it will automatically load the whole data. All right. So that's about the partition tables. Now, just like any other SQL, you can alter the table name by using alter table rename to. You can change the column data type. Say, for example, here we are changing the column from HMS to hour, minute, second. Okay. And sometimes we can also want to add more columns. We can do that at later point of time. Sometimes if we want to delete a particular partition, the way we have a partition here, partition could be on multiple columns, the way we had for single one. Like we can create a partition in 3 variables, or sometimes we can just delete a partition. Okay, so that was our external table. That was our external table. So we can say create external table mini wiki stats, and then partition by a particular column, and row format delimited fields terminated by something, and lines terminated by something. Okay, so if your data is in S3, you can load that also into an external table. The benefit of having an external table, okay, I think I skipped this particular slide. Right. So in the same fashion, the way we have been doing so far, we could also create external tables. Beauty of external tables is that if you delete an external table, the data is not gone; it's intact. All right. So we could create external table like this. Okay. Say row formatted for row format delimited fields terminated by /t, and location equals to this. All right, you can see that. So we are saying create external table if not exist, and the only keyword extra is external. Now, the only difference between external table and internal table will be if you delete this table, the data at this location will not go away. Okay, sometimes you can have external table on a remote server such as S3 by simply saying S3 here in the protocol. Okay, there's not much of a difference. And sometimes you can also define the partition. If you know that your data at this place is partitioned by such a criteria, then you can do that and start querying the table right away after you have done. So, okay, so sometimes you can have external table as partitioned, meaning every partition is can be an external. So, for example, imagine that we have external table called log messages. It has got 3 columns, and it has got 3 more columns based on which the data has been partitioned. Okay, so it has got not 3 columns, it has got 1, 2, 3, 4, 5, 6, 7, 8, total 8 columns. And this is what you have will be providing from the partition values. Now, In this kind of a table, we can alter a particular table and add a partition and say that, hey, uh, this is my location. Okay, this is the location of my data for this particular partition where year is equals to 2012, month is 1, day is 2. And sometimes you can, and you can also add another partition called set this for this particular period. You could add one more partition from S3. So the idea which I'm trying to explain here is that your single table could be on multiple kind of different files altogether. Okay, it could be completely on different kind of files altogether. So that's a very important aspect of external table. So as we told that Hive, objective of Hive is to be able to churn the data located at multiple locations and with providing a very simple SQL. Okay, so the external partition is exactly for those reasons. Now, again, let's just do a recap. Every table has got a location. Either it's located at the default table. By default, it's located in this directory called apps hive warehouse. You can override this location by mentioning location in create table clause. Location load data copies data if the data is local. So if you have some file locally, as in you're running Hive from the command prompt from here. Okay, so if you are running your data, your Hive from here, okay, in those cases you could use the you can load the data from local. Okay, now loading data from local is not supported in the query editor here in the Hue, but you can load the data from HDFS. If you load the data from HDFS, data moves into that location. Okay, whether the table is external or internal or managed. And internal and managed is the same thing. Dropping managed table deletes the data at the location as we described earlier. Dropping an external table does not delete the data at that location. Metadata is stored in relational database such as Hive Metastore. Okay, so that's an important aspect. So metadata is stored in Metastore, and here this data will be somewhere lying in MySQL. All right. The select statement could be really complex. It could be you could give a name to each table like here, or you could directly call without the name for the table. Sometimes you might want to do the computation on columns, as uh, somebody was asking that in case you have a map, deductions called map, you want to load that data, you can load that data using the square brackets. And you can also do a complex algebraic computation like this easily. All right. Do you have an example where we put all the Hive commands in shell script? Okay. Yes, we have an example and it's not a big deal. So what you can do here is, how do you, let me see. So if you are running from the command prompt, you could say hive my script dot SQL and it'll run your script if you have this script as a file. Okay, that's not a big deal. Whatever we have written here, it's actually getting executed like a single file. It's internally creating a temporary file, putting all of this data into a file, and then running it using Hive. Okay, so that's not a very big thing. I think that's what you wanted, Naveen. See, this question is dropping table did not delete meta. Yes, it does. It does. Okay. There's a, No matter whether the table is external or internal, it always delete data from metastore. All right. So, okay, so that's how you deal with the lost general queries. All right, let's take a break and discuss the things from aggregation onwards and views. Hi everyone. So I'm back. Should we start now? All right. Should we start now? Is everybody back? All right. So question from Veena is: do we have class next week? Yes, we have class next week. Okay. The reason is that we need four more sessions to finish, and I have another class coming up on 5th. So we cannot afford to have the off on 28th. All right. So Thanksgiving is on what date? It's on 28th or 29th? All right. So the only problem is okay. So all right, then I'll have to inform my morning class as well. Okay. So all right. Who else wants it holiday on the next weekend? Veena and Ganpati both. Who else wants a holiday on the next week? Ravi and Arjang. Oh wow. So by any chance, is it possible to take it on the weekdays then? Not possible. All right then. Okay. So looks like okay. Based on the votes, let's just have the uh no. Okay. So we have holiday on the next weekend. All right. Then we will have holiday there. All right. Okay. So looks like everybody is okay. So we will have holiday on 28th and 29th. Okay. All right. Although I'm running really tight at this because yeah, I kept 2 weeks gap. Never mind. So let's continue the discussion. All right. So sometimes we have uh, these aggregation functions such as count star, average, and sum, and Hive provides you the tricks to optimize them by setting a map side aggregation. Lots of aggregations such as count star, average, sum on the whole column without any filter or without any group by can be actually performed using a combiner and on using the map side operations. Okay, using map side operation, and that is very useful. So you can improve the performance of your Hive query by setting Hive map aggregation equals to true. All right. Now that was not that important. The important part is that Hive also provides you a way to create views. The way you have views in normal database, you can create views. Now, what is the difference between a view and a table? Table has data, view does not. View is a representation of the query. It is for simplifying your query. For example, here tweets clean, this is tweets clean. Tweets clean is a view that represents this whole query. Every time you say select star from tweets clean, it is going to execute this query. Every time you query tweets underscore clean, it's going to call this query. And that is the beauty of views. So you can simplify your logic. You can simplify and write very modular queries using views. Okay. Now you can also customize Hive by creating UDF function similar to your pig functions. The way we created pig UDF as in user defined function, you can also create user defined function for Hive. Let's say there is some function which is not available in Hive library that you can write it in Java. So all you need to do is while creating a class, other than doing the import, defining a package, this typical one. This is the package which we have defined, and these are the imports which we have done. And here is my class definition. Also note that every function you define, every user defined function is a class. It extends UDF, and then it has a function called evaluate. In evaluate, you can put whatever data type you want to put here, and you can put whatever data type you want to put here. And then you can do this kind of magic. So I'll show you a real example end to end, a working real example end to end. You can also download, you yourself can also try by downloading the data from here. You can download the project, not here, I think here. Yeah, you can download the example project from here and then import it after unzipping it. You can import it from there. All right, now let me try to show you that. All right, I think we have deleted the folder. All right, never mind. I think I should show you from the beginning. Let's download this UDF project. Okay, click on this and then click on the download this thing. And once you have downloaded, then once it is downloaded, then we will do. Let me just close all the files. All right. So once you download, you will see that the libraries are there. This doesn't have any significance. You can delete this, and you can also delete this folder. And this src folder has got this code which we have. Okay. So in your Eclipse, you can say import and then existing folders, and then browse to the download directory here. Where is the downloads? Here you can see that there is a folder called UDF. You can say open. Now here it will give you the all right, let me first delete my old one. Or okay, let me delete this. All right, let me import. All right, so now we have imported. Everything is clean. In case you get error, you try to change, clear these libraries, reference libraries, and add again. Now here is my code. Here package is st, and there are these import declarations, and here I'm doing this. Okay. If I want to put something like in the beginning, I want to put this. Okay, and at the end, I want to put again semicolon, just like that. So just like that, I'm trying to do so that we know that it's our code that is being executed. Now I'm saying export and Hive UDF and finish. So it's in download folder we have done that. Now let's go back to first file browser. File browser, let me go to home folder and then go to sgiri folder. because I don't want to pollute the whole place. I just want to keep it in my folder. You can see here. Now here I can upload. Where did it go? So I can just click here and say. So here, let me just upload my file, the one which we have just created. Good. So we have uploaded our HDFS in our file in HDFS. Okay. Now here, let's try to execute. Let's try to utilize that particular file. Okay. So we have done this, but we don't need to copy it to server. We just need to copy it to server using Hue. And then we can say things like add jar, and here instead of this we have to say asgiri as well. Okay, now in the next line, so we are saying add jar, and then we say create temporary folder, and then say this. All right. Now, what is it we are doing? Also, please note that here the class name is lower, so we'll just keep lower and my lower. Okay, so this is correct, right? Yes. Good. Now here you can see that what are the things we are doing? We are saying add jar from HDFS. Okay, we are our UDF is in HDFS. If it was in local file and we were running from the shell, we could have said file colon colon, or we couldn't have said anything at all. We could have just given the path name. Now we are saying create temporary function mylower as this, select this and this. Okay. Now let's try to execute and see what happens. So we are calling mylower on multiple things. Okay. This is a little different. Why did it not give the results the way I wanted? All right, mylower st.lower, and I'm saying this. This is the place we have uploaded our data. 8:53 a.m. Is it of morning or is it of now? So let me just delete it. And upload again. I'm uploading that file again. So today at this time, all right, let's try to do it again. All right. So we are saying add jar. This is the location of our jar. Create temporary function mylower and this. Select this. Okay, let's try. I hope we made the modification at the right place. We had put this colon and semicolon. Why is it doing this way? If I say this and temporary function 1, not this, 1 and 1, and here let me say I'm renaming my file. Okay, I'm renaming my file. Did it happen properly, right? This is crazy because there is no such file. Okay, there is, yeah, there is this file now. All right, I need to figure out why did it do this way, or why didn't our change go into this. We have put in colon and just like that. All right, we'll see to that later. But for time being, let's just go ahead that we were able to successfully call our external function. All right. So that was our Hive UDF. Sometimes you have to load the data from various kinds of format, and that is called JSURDE. SURDE as in serializer, deserializer. So sometimes your data might be in different kind of formats. Complex formats may be in JSON or XML. In those cases, you might have to use third-party binaries. And you can do the same way. You have to do first add jar their library, the way we have just done add jar for our library, and then call these functions in the same manner. All right, you can call these functions in the same manner. All right, so you can see, you will see that later that while loading the data, we how are we using this JSON survey? As in, if our data, this data tweets the data that's going to go in this table, if this data is in JSON format, now I want to represent it as the table format. To do that, we are going to use, we can use this third-party library, and this third-party library can be added to our Hue this way, and then we can start using that particular row format. Instead of saying delimited by something, we are saying this is our serializer deserializer, and this serializer knows how to convert JSON into the database table. All right. Now, so by default, Hive gave us a syntax called order by a particular column. It was nice, it worked fine, but the problem with order by was it was routing everything through a single reducer. It guarantees the global ordering. It does it by using a single reducer. This was unacceptable for large data set, and though you get one single sorted output. Now, so that's when the idea of sort by X came into play. Sort by X made the data pass through multiple reducers. The number of reducers again are decided. Number number of reducers are decided per one. Okay, based on decided like this. Decided and are one per GB of input. Okay, so orders data at each of n reducers, as in, if you remember our discussion earlier. So basically, when we had multiple reducers, data was ordered by the key, but there were overlapping ranges in the two output files, which means that our word count problem without a proper partitioner, if you it was giving us two files, right? When we said that we want two reducers, it was giving us two files. Now the two files, if you try to combine them or concatenate them, the data is not ordered, meaning that maybe one file has A, B, C, other file has A, B, B, C, C. Now, both of these files are individually ordered, but if you try to merge them, again a lot of effort is required. In those cases, what we did earlier was we defined a partitioner. In the same way, here we are defining a new syntax Hive has provided called sort by. Sort by ensures that it has our data goes through multiple reducers, but it doesn't lead to the distinct ranges, right? It only says sort by only make sure that the data goes through multiple reducer. So for that you have distribute by. So distribute by X ensures that there is a partitioner. Partition is created based on the hash code, and it ensures that the data is not overlapping in two files. So that if you combine sort by and distribute by, you will get the proper result. What are we saying? We are saying if we say there are multiple reducers, but there is a partitioner, then we will be able to get the data which can be concatenated, and still the overall results will be ordered. Okay, so that's what is cluster by, or a combination of distribute by X and sort by X. So it ensures that. So let me try to write it. Yeah. All right. So the syntax looks like this. Okay. So the syntax looks like this. All right. So you can do a cluster by and make sure that the data is properly ordered. Okay. So you could say cluster by a particular column, and then the data will be ordered properly by that particular column. All right. So that's about ordering the data. So in the end, we will be using cluster by instead of order by in the summary. Okay. Now sometimes you want the tables to be automatically partitioned, or you want tables to be automatically separated based on a certain criteria, right? So if you remember our discussion on partitioning, in partitioning we were importing data, we were specifying which data belongs to which partition and so on. That is not something great if you want it to be automated. Also, partitioning was creating lots and lots of folders, and also partitioning was based on the linear behavior. The folder name were based on independent files were divided based on individual data. Okay, individual value. So every value, like every year, every month, you will have separate file, but that's not great. That's not great. You don't want too many partitions, or you don't want. So sometimes the crux of the matter is the sometimes partitioning doesn't suffice, and that's where comes bucketing. We say that we can bucket this particular table called page view into 32 separate files. We can slice this table called page view into 32 separate buckets. And this bucketing happens based on the hash code of this user ID, the column on which we are bucketing it. So based on this column, there are 32 buckets that are created, and the ranges are dependent on that. So this makes us our life easier because it creates buckets. So when we are querying the data and we are filtering the data, we are saying only give me those records where user ID equals to this. In that case, it doesn't have to scan the whole data. Instead, it will just look for that particular bucket. All right. So this is called bucketing. It's not very difficult concept, just that you can define it like this. When you say cluster by something and into these many, then it will split the table into 32 buckets. Please note that this syntax cluster by into this is different from this one. Here we are ordering the data. Here we are slicing the data into multiple buckets, right? So let's have a quick demo of what it looks like. So let's say you have this table called EU data. Let's create this table here. Okay, so we have created the table successfully, and we can say user data. There is no data right now. All right, so next is we already have this downloaded. Let's try to load the data from there into our file. Okay, so but before that, let's first make a copy of the data, or we could also do things like, let's just, instead of this, I think we should drop this table, drop table u underscore data. All right, and then we should create an external table. All right, we should create an external table. Let's try to create external table, this. Okay, it doesn't matter, I was just trying to show you that. Now let's go to the file browser, and here do you see any folder with right? Let's go to the data folder. Let's make a copy of data. Let's make a copy. So here, these are the ratings of the user. These are the if you look at this data, you can look at this data. What is this data? This data is the movie lens data, which is which user has given how much rating to who. Okay, so let's copy this data to our home folder. Okay, let's copy this data to our home folder so that we can comfortably start importing this. All right, so we have made a copy of the data in our home folder. All right, so here there would be somebody called as key folder. Under that, you can see that we have created this u.data here. All right, you can see that. Now what we are saying, create an external table u underscore data with these values, and this is the information. Let's try to import the data. Let's try to import the data. We say load data. We say load data not local but from HDFS, and this is the folder which contains the data. Okay, here we can simply copy this location. We can simply copy that location. Okay, we are saying load data input path this overwrite into this table. It says the data has been loaded. Now you can start churning this particular newly created table. Correct? So this is, now you can see that user ID, movie ID, ratings, and then at what time did this person rate this particular movie. Now what we can do here is we can do a lot of things. Let's say we want to find out the average movie rating. So we could say movie ID, comma, average of rating from u underscore data group by movie ID. We are trying to find out the average movie ID. All right. What does it say? I hope everything is up. All right. So I need to see what is going on. See, this question is, do you have index of topics to prepare for interviews? Actually, these the discussion which we are having, this all is a good recipe for the interviews. What is this? Failing because I'm unlikely to write to. Oh, I see. All right, I don't know what's going on here. Veena, now the voice is okay. So TEMP Hive is something which is giving trouble. Alright, there's something seriously wrong. How do you end a session? So we are saying select star from u underscore data, and I'm saying limit 100. Okay, now let's try to do a group by. We are saying movie ID, comma, average of rating from u underscore data, group by movie ID. All right. All right, there's something wrong with this. We will see that later because I think for you the query will run fine. Maybe I just need to look at what's going on. Okay. All right, never mind. So great. So basically, you can run this query. Maybe something wrong has happened because of my earlier I've cancelled a couple of sessions. All right, never mind. So the assignment for this is so I've just run a very simple query. So assignment for you is for each movie you have to find out how many users have voted for it. For movies having more than 30 ratings, what is the average rating? That these are the two assignment you have, and yeah, that's pretty much about Hive. Okay, is everyone with me? No. Great, great. All right, then should we start? I think we should start with the zookeeper part. Okay, or should we start with Spark? Because understanding zookeeper is quicker and easy. So I think we can start with Spark. All right, let's just go with zookeeper. All right, where is our zookeeper? All right. All right, so we want to discuss something about Zookeeper, and after that, we can go ahead with the rest of the syllabus. Okay, so this is very important to all of you, and let's just pay a little bit more attention because these are the real questions. If I'm the interviewer, I'm going to ask these kind of questions to anybody who comes into big data. Okay, and these are the questions which get asked if you are looking or aspiring for big data developer or architect or anybody who uh, who is into handling the various kinds of products. All right. So is everybody with me? All right. So we're starting with Zookeeper. We have finished our hive. So question to all of you is: let's say we are processing email boxes of all the users, and we are not allowed to modify or make any changes to these inboxes. We are not allowed to do that. So, and our email processors are running on our cluster on hundreds of computers parallelly, accessing hundreds of users' email accounts. So, something like this. We have email processor 1, 2, and 3 is reading from inbox and email 1, email 2, email 3. Now, how would it work? How would it work? What are the challenges do you think there would be? Anyone? These kind of things were easy, relatively easy when you were running it on a single machine. You were running these processors as separate threads. These kind of things were far more easier at that point of time because you could always create a lock on the inbox, thread lock, and then we could the other thread would not enter. Okay? Because otherwise, if you do not lock or you do not try to protect against concurrency or race conditions, what you will end up overloading the inbox, or you will end up corrupting the data. Okay? Sridhar is saying once read is done, it will be marked as read for an email. Now let's say both the processors started reading the same email. How will you do about it? Well, how would you protect two email processors reading the same email ID? How will you protect against that? Yes, good question, a good answer. That the email will be marked as read, and therefore the other email at later point of time may not come. But two email processors might try to read the same email at the same time. Correct? Anybody else? Is the question clear to everyone? Martin, Veena, Saryur, Naveen, Randhir, Ganpati? Ravi saying, so the email object needs to be synchronized. Very good point. Just that that kind of luxury is already only available when email processors threads are running on the same memory. On the same computer, you can synchronize. What if here what we're talking about, these boxes are on different computers. Email processor 1 running on one computer, email processor 2 running on different computer, and email processor 3 running on a different computer. And the moment two processes run on different machines, the thread safety or the synchronization doesn't work. All right. So the question is, you wrote this really brilliant email processors. What these email processors are doing, they're processing your emails for, let's say, spam, or maybe these email processors are just picking up the emails and creating some kind of putting it into some kind of, let's say, group email, or maybe issue tracking. I mean, or maybe a support system. So those kind of work these email processors are doing. Okay, good, good. Let me just paste this answer. So, okay. So the problem statement here is, when multiple email processors are reading from the same inbox, these all email processors might end up reading the same email. We want to avoid that. We want to avoid that if one email processor is reading some email, others should not get into it. Okay. Vinay is saying we need to have a data store where email processors can check before reading. Brilliant. And same is the answer from Ravi. So talk to one element that knows about emails. Good, very good. And what Veena is saying, this is what we are going to do. So we are going to have something called a central data store, in which email processors are making a note saying, hey, I'm processing this particular email and I'm processing that particular email. So that two email two email processors do not try to process the same email. Okay, before going to process this data, email processor is going to read from this under process kind of object and check, is somebody reading this email already? If yes, then don't go. If no, then mark here and go. All right, mark here and go. So that kind of model is required. Now, building such kind of system where under process kind of a system is actually fairly difficult, because this itself will suffer from concurrency. What if two email processors tried to talk to another process and it crashed? So building such kind of systems is fairly difficult, and is very much required, right? So now thread safety is something not possible. In distributed computing, when your programs are running on multiple machines instead of multiple threads, the whole idea about threads and semaphores and all that monitor, those guys who are from C background, you can correlate. The whole idea about threads go waste. Okay, whole idea about threads need to be revisited, and that's where Zookeeper come in. So this box, you see the under process box, this is what the Zookeeper is. Okay, this is what the Zookeeper is. So what is a Zookeeper? Zookeeper is a coordination service for distributed application. So when we say HBase need to find out about its reason servers, they did it via Zookeeper. So the way it worked was, whenever reason servers were coming up, they were informing Zookeeper, hey, I'm up. If HBase master comes around, let him know that I'm up. Okay, so it's a coordination service. It helps various application coordinate. Okay, so that the individual services don't need to write this logic of coordination. Instead, they can happily rely on Zookeeper. Okay, so Zookeeper is a service. It's a process running on a particular port, listening to various calls from various users, and it exposes a very simple set of uh, uh, instructions or primitives. It's very easy to program to, okay, and it uses a data model like a directory tree. Let me tell you a small information. So earlier, when I was building the Kibitz global product, so there we were having the email processors. Now these email processors were picking up the email from the inboxes and were running in a thread. Okay. Soon enough, we realized that it's not a good idea to run it in a thread because it's going to be on multiple processes. So what we started doing was we started saving this information that which email is being processed into a common folder. We started creating empty blank files with the name of the ID of the message. Okay, empty files with the id as the name of the file. So that's how we were trying to resolve this kind of problems, and that's exactly where Zookeeper fits in. Zookeeper provides you a data model like a directory structure so that different programs can put their data or put their messages in different folders in the form of data. Okay, so it does provide you a directory tree. The only difference is that it doesn't have an idea of, it doesn't have this concept of file folders and files. Everything is a node, and node stores data, and node has other nodes as children. It's used for synchronization, it's used for configuration management, maintenance, it's used for, it doesn't suffer from race conditions and deadlocks. Okay, so the design principles, the design goals of Zookeeper were pretty simple. It's a hierarchical namespace that looks like a standard file system, but under the hood, it has something called data nodes called Z nodes. Okay, so it has called Z nodes as in it's a tree structure where you store the data as well as you have the children, and data is kept in the memory and also in the disk. So please pay attention to this particular point. Data is stored in memory, therefore you cannot have Zookeeper for large data. It's for small data for concurrency. Achieve high throughput and low latency number. High performance used in large distributed environments. It's highly available. There is no single point of failure. This is something very interesting, and this is the reason why I have included Zookeeper in the syllabus, that it's a highly available and there is no single point of failure. There's a strictly ordered access and synchronization. Strictly ordered access is equivalent of synchronization, and strictly ordered means the one who came first should get the data first. Okay, should not be there should not be any doubt about the ordering of various processes. Okay, now it's highly replicated, it's heavily available and is replicated. So the way it works is there is this Zookeeper service which is made up of many servers. Zookeeper is not a single server, it's a bunch of servers. There are hundreds of servers running and listening to it. So the clients always stay connected to the Zookeeper. So so the client keeps a TCP connection. Clients keep get watch events. Clients keep on sending heartbeats saying, "Hey, I'm alive. I'm alive. Don't assume my session to be dead." Okay. So the servers know each other and keep the image in memory image of the state. And also, all of the data is kept in the transaction logs and snapshots. The third is ordered, as in Zookeeper stamps each update with a number, and that number is ordered transaction so that the synchronization takes place. It's really fast. It was tested at Yahoo, and it was considered really fast. As in, the ratio of read to write was 10:1, and it has been clocked to 10,000 operation per second. All right. So let's have a look at what's here. So first of all, let's check this server status using the four-letter commands like are you okay, conf, env, and server. Let's go here and say echo are you okay and send it to nc localhost 2181. It says I am okay. See that? It is replied saying I'm okay. Similarly, if you want to see the conf of this, you can see the configuration of the zookeeper. All right, so that's about checking the configuration, although it's not very much required. Something you can also check, is it read only? I'll talk about why it could go read only. It says read and write. You can see the response. So this is like admin status of the cluster. Now you can simply download the Zookeeper server and start using it, but I would again strongly recommend that you go with Ambari way of installing Zookeeper. All right, let's understand the data model. All right. Right. This is a very good point, what Ravi has said. Shouldn't the heartbeat apply to server saying I'm alive? So everybody for Zookeeper is a client. So let's say one of the clients is Reason Server. So Reason Server has connected itself to Zookeeper and periodically keep telling that, hey, I'm alive. Don't consider me to be dead. Don't delete my session. I'm alive. So it keeps on sending the heartbeat. So the client, when we say client of Zookeeper, is actually all kinds of services, whether it's HBase or whether it's Reason Server or whether it's Kafka Queue or whether it's Kafka brokers. So all kinds of systems in the ecosystem, they keep their data in Zookeeper, be it name node and backup name node. Okay. Practically, do we usually have Zookeeper in clusters? Yes. This is one service which you cannot live without. Okay. Here Zookeeper is there. It is showing as stopped, but it's not stopped because there is some one layer of library that's required by Ambari. So it's always there in every ecosystem. All right, coming back to the point here. All right, so let's understand the data model. Data model is like this. This diagram is probably the best. The top level node is called slash. It also has some data you can get and put to this. And every node has got children like slash Jew, slash duck, slash goat, slash cow. And you can always think of it as a highly available file system. Each Z node can have data. Each G node can have children. Z node form a hierarchical namespace. Z node also have something called access control list. Why? Because in an organization, the when you have multiple applications, you might have to have the access control list. All right. There are no append operations, either you write or error. Okay, so that's what it is. It's also, unlike file system, this is not equal to this. It gives an error. Similarly, unlike file system, this is not equal to this. All right. Now, Znode, what we just talked about, Znode form the whole of namespace. Znode forms the whole hierarchical storage of Zookeeper. Now, there are different kind of Znodes. One is called persistent, meaning they remain until they're explicitly deleted, or ephemeral. These are deleted by Zookeeper as the session ends or times out. Now, ephemeral nodes sounds strange, but you will find out that ephemeral nodes are very, very important. So ephemeral node, so a user has connected to Zookeeper and created an ephemeral node. In case, in case this user disconnects, the ephemeral node will disappear. Also, the ephemeral node will disappear if the user automatically has got a network connectivity problem. So, ephemeral node cannot have children. They are tied to the client session but visible to everyone. All right. So you can have, there is another node, G node called sequential node. These are interesting nodes. Every time you create a sequential node, it automatically appends a big number after that names, after that uh, node's name. For example, we are saying create zoo, create minus s, meaning sequential node zoo, and put the data as v. Okay, so inside this is the data. So you know what it will create this. Okay, and as we keep on creating more and more such nodes under, so we are saying create zoo starting at this location in the folder called slash. We are trying to create a node, a sequential node with zoo as the prefix. So it will create a sequential number after this. If you create next sequential node, next node or next sequential node under this slash, it will have another ID. Say for example, if you go with this, but if you are creating in, so every G node carries their own current running number. For example, right now slash is carrying 8, and now after this slash is carrying 9 as the running number, but slash juice slash is carrying 3, and so on. So the number keeps on increasing monotonically per Z node. Okay, so let's try to run through this. Okay, let's try to create all three kinds of nodes. So we can say zookeeper client, zookeeper client, you can see that. All right, let's say what is the status. We can say status. All right, now let's say we have create minus s, or let's just create some node called let's say 17th OCT. Okay, 17th OCT, and we put some data in it. So this is our normal data node. Okay, not data node, these are G nodes. So we have created 17th October. Inside 17th October, we could create the nodes like further inside this. Let's try to create a sequential node under 17th October. Okay, so you can see that it starts with 0. We are creating the node under 17th October. We could also say X here. So you can see now the number has become 1, though the prefix is different. And we can keep on doing this again and again. It will keep on monotonically increasing. But if you try to create any other node, say Y, okay, now if you go back, the number will still increase. So you can see 6, Y, and then 8. So the number is continuously increasing. It's a count of how many nodes have been created under a particular node. Okay, so under this particular Y, let's say under this particular Y, if we try to create another sequential node under Y, now the number will again start from 0. You can see that number will again start from 0. So we are creating the sequential numbers. All right. Now, in the similar tone, we could also create a formal node. Okay. Let's say we could also create minus e and slash 17th October my EMPH. Okay, with some data. Okay. So now you will see that when we say ls slash 17th October, we'll see all kinds of nodes here. Now this my EMPH is still existing, but it'll disappear after like 10 seconds because it was created in another session. So we are able to create various kinds of nodes. Also, please note that although this ephemeral node looks like temporary, but till the time it's alive, it's visible to all. Now you can see that it has disappeared. It has disappeared because we created in another session and then exited and then started this Zookeeper client again. Now, you might be wondering, what is the point, what is the use of ephemeral and these nodes? So sequential node is clear to everyone that for each z node, is each parent z node, there is a running number, and that number is appended to every sequential node that's created. Right? This is very useful in the cases where we are building a system like kind of a support server where we have to generate IDs for our support requests. Every support request has to have a running number, or we are generating some other kind of number. So for those, you leave the responsibility of creating these unique numbers or running numbers to Zookeeper, and then you can utilize that. And with ephemeral, we can keep a track of which sessions are up, which sessions are down. It's like taking attendance. All right. Now, there are many things, many functions which Zookeeper provides you, starting with create, delete, exist, and ls, get ACL, as in get the access control list, get children, get data, set data, and sync. So get data gives you the data, synchronizes, syncs the whole view of the client from the server. All right. Now, again, whatever we do in case of Zookeeper, because Zookeeper is supposed to provide you all kinds of flexibilities, starting with transaction to multiple updates. So, multiple update means in a single transaction, we could do everything: create node, delete node, update node, and create a couple of sequential IDs and so on. We could do all of that using multi-update. So you could, just like in our databases where we could batch together hundreds of queries in a single transaction, you could do the same thing with Zookeeper also. The API with respect to the Zookeeper are basically into Java and C, and the API is contributed for Python, Perl, and REST. And for each function, you have both kinds of both kinds of for each both kinds of bindings available. There are two functions for each functionality. For example, if you want to check exist, there are two functions for checking exist. One is synchronous and other is asynchronous. Synchronous is the one where when you call a function on Zookeeper, you have to wait unless that finishes. Async is somewhere you return quickly when you make an asynchronous call, you get immediate response saying, hey, I have accepted your request. We will let you know once we are done. Okay? And that therefore, in case of asynchronous request, we need to provide a callback method, which can be called once that particular function finishes. So when exist finishes, this callback will be called. All right. Also, also there's one great functionality from Zookeeper is that all the watchers of people can subscribe to various kinds of events. Clients can subscribe to various kinds of events saying, hey, let me know when this node gets deleted, or let me know when this node gets updated. So users can, the client users, the, the various kinds of clients of Zookeeper can subscribe to various kinds of events. Also, when a user subscribes to something, they are executed again. In case they want to keep on getting updates again and again on a particular node, in those cases, on every trigger, they should basically re-register itself, just like we do it in JavaScript. Okay, so these watch triggers are interesting aspect of Zookeeper. So the various kinds of read operations such as exist, get children, get data all have watches. When we are calling these functions, we can also inform that here is my function which is a watch. I want to create watch in this particular node so that anything that happens to this node, I should be informed. Watches are triggered by write operations such as create, delete, and set data. ACL operations do not participate in watches. Okay, so watches of exists are triggered when that particular gnode on which exist was called is created, deleted, or its data gets updated. Watches of get data gets called when that particular node on which the get data was called, if that particular node gets deleted and has its data updated. Watches of get children gets called when the data gets deleted or any of the children is created or deleted. All right. So ACL, the access control list, determines who can perform what on certain operations. Why do we need it? Because as we just told that Zookeeper is going to be used by lots and lots of users. So it's important to have access control list. The access control list can be is a function of authentication. Okay, authentication can be of three types. One is digest, as in login password, SASL, meaning Kerberos, IP, as in based on the IP address. Okay, so ACL is essentially a combination of authentication, the log name of the person, and identity of the scheme, and a set of other permissions. So authentication and authorization is what is ACL. All right, let's understand the most important aspect of Zookeeper. This is something very, very important. Rest of the things are okay, good, we are able to understand it, but this is something which we have not studied so far. So, Zookeeper runs in two modes. One is standalone, which is just for testing. Another is replicated, which runs on multitude of servers, on n number of servers, meaning so you turn on the Zookeeper on all these machines, and we call that as ensemble. Okay, we call that, okay, we have 10 Zookeepers in ensemble. Now, in this ensemble, what happens is the voting starts. So the first thing that happens, this is something very interesting because in case of HBase, we had master slave. In case of HDFS, we had master slave. In case of Yarn, we had master slaves. But here, the master and the slave is automatically decided. So you have ensemble. When we start Zookeeper, you have ensemble of machines. You have ensemble of machines. There are like 50 machines in the ensemble. Now these machines, they elect someone amongst them as leader based on the ping request. All these machines ping to each other, take a note of how much is the response given by who, and based on that, they nominate somebody as the leader. That's a distinguished member. The others are termed as followers. This phase is finished when majority syncs their data with leader. Okay, so leader has been elected. The others are called followers. Followers have to sync their data from the leader. In case the leader fails, the remaining machines will hold an election and choose somebody else as leader within 200 milliseconds. Are you guys with me? Now, all the right requests whenever somebody is trying to modify the data, create a node, update a node, change some data, all of these things are called write requests. So these write requests, these requests for changing the data are forwarded to the leader. Only leader accepts the write request. Everybody else just gives the read request. So leader broadcasts, whenever leader gets an update from the client, leader informs all the followers that hey, there is a change, there is a new change we have received. And when majority of the machines have saved the data, then leader informs the client that hey, your update is successful. Okay? So the protect protocol for achieving consensus is atomic. It's like a two-phase commit. Machines write to the disk before they write to in memory. Therefore, it's heavily persistent. Okay. Now, please note that here what is happening is every change which leader receives is sent to all the nodes. That means if you have 50 nodes and you are saving 1 gigabyte of metadata, that means all 50 nodes will have 1 gigabyte each. And therefore, the resultant total storage will be 50 gigabyte. Okay, and if you have 1 gigabyte of metadata, that means 1 gigabyte of data, that means it is going to consume the full RAM. It is going to consume 1 gigabyte of memory. Alright, same thing has been depicted here. All the read requests are being forwarded to the leader, and the clients are forwarding the request to the leaders. Do you see that? Alright, so there are so many clients, they are reading from everywhere, although they can read from the leader also, but write requests are redirected to the leader explicitly. Now there is a very important aspect. There's a very important aspect. I think we should cover it maybe tomorrow. Alright, let's cover it tomorrow. So we have talked about the election and then we will talk about rest of it tomorrow. Alright? The dotted line is internal communication between followers and leaders, is basically synchronizing their state from the leader. Alright? Alright, so we will talk about this election tomorrow again and we will get into more details tomorrow. Alright? Bye bye. Have a great day. Thank you, Veena. Thank you, Ravi. Thank you, Martin. Thank you, Sridhar. Thank you, Sharyu. Thank you, Naveen. Thank you, Ganpati. Thank you, Randhir. All right. Bye bye.